Hello students, I hope you all must be doing well. So in the last session we discussed about the concentration term, we discussed about the solubility. So in today's session we will discuss about the concentration term, because in the last session I told you that concentration term is also like very important. Although most of the students completed or most of the teacher taught this concentration term in the previous classes, like in 11th mole concept chapter, but still today we will discuss about the concentration term, because this becomes the crucial part for the solving of the solutions numericals. Okay, so without taking so much time, let's start the chapter. So in the concentration term, let us know that what thing we are going to discuss. So number one, we will discuss about the percentage term, and in the percentage term we will discuss about the weight by weight percentage. Number two, we will talk about the fraction term, and in the fraction term we will discuss about the mole fraction. Okay, because this mole fraction thing is important for to solve the Henry's law problem as well as the Rolle's law problem. So mole fraction term is also quite important. Next we will discuss about the molarity. Next will be the normality, and last but not the least, that is molarity. And there is also another term that is called formality, which is not required in this chapter, but still we will discuss on it. Okay, so finally we will discuss about the formality. So starting from the percentage term, what do you mean by percentage? Whenever I am talking about percent, it means the cent word stands for 100. So anything out of the 100, let's suppose I'm talking about, let's take an example. If I'm talking about 5% NaOH weight by weight solution. Okay, so what I usually understand by this term, let us understand this, what actually the thing, further we will discuss about the formula and all. So here we will, let us understand what actually this term tells about. So it has said that 5% NaOH weight by weight solution. What does it mean? It means if I'm talking about weight by weight, that means if cent means 100, right? So the cent word must be, that will be in the denominator, and something will be in the numerator, that will be 5. That is called your percent. That means 5 out of 100. So if it is told about that is weight by weight, what does it mean? It means that is if I will consider that is the solution mass, okay, the solution mass as 100 gram, then out of the 100 gram, 5 gram of sodium hydroxide is present. Okay, that means if I want to understand this term, that I can easily tell it like 100 gram of solution, 100 gram of solution contain 5 gram of sodium hydroxide. Okay, so if I want to simplify it, that means there must be the sodium hydroxide must be the solute, and rest of the part will be the solvent. If I'll say like yes, 5% aqueous NaOH, so it means what? That is the weight of NaOH is 5 gram. If the sodium hydroxide is comprising of 5 gram, then the water must be of 95 grams. So 95 gram of water and 5 gram of sodium hydroxide are mixed together to give a aqueous solutions of 100 gram mass, right? So usually I understand like this. So at the same time, if I talk about like 98% of H2SO4 by weight, okay, if I'm talking about 98% of H2SO4 weight by weight percent, what does it mean? It also means that that is 100 gram of solution, 100 gram of solution. Which solution? Let's suppose H2SO4 with any kind of solvent you have taken, right? So H2SO4, so 100 gram of solution which is prepared by mixing H2SO4 and any kind of solvent contain 98 gram of H2SO4. Okay, so we usually understand this, that is अगर आपको बोलता है कि weight by weight percentage बोला है, so I will consider the solution mass as 100 gram and I will consider the percentage whatever has given to you, that will be as an mass, that will be the mass of solute or it can be the mass of solvent. So from these things I can easily make a formula like how to find the percentage, right? So if I want to calculate the percentage of solute, right? So if I want to calculate the percentage of solute, so here the formula can be right as, that is a weight of solute by weight of solution by weight of solution in 100. Similarly, if I want to write the percentage of solvent, so the formula can be written as weight of solvent by weight of solution into 100. So by these two formula, I can easily calculate the percentage comprising of solute in a solution and the percentage compositions of the solvent in a solution. All right. So let's take an example. Okay. So let us assume a question like, yeah, let's suppose 50 gram of sodium hydroxide mixed with enough amount of water enough amount of water to form 250 gram of aqueous solution. And the question is asked, calculate the percentage composition of water. Calculate the percentage composition of water. Okay, let us understand the questions once again. Okay, so what is asked in the question and what is given in the question, that is most important thing you need to keep in mind while solving a numericals. Okay, so let's see that what is given to you in the question. So the question is asking, that is 50 gram of sodium hydroxide mixed with enough water. So that means sodium hydroxide has mixed with water to make a or to prepare a solution that is called an aqueous solution of 250 gram. Matlab everything like this mass, the your solute data, your solvent data and your solution data has given in mass. Okay, and it has asked that calculate the percentage composition of water, or I can say that is the mass percentage compositions of the water. Okay, so from these questions, let us given data kya given hai. Let's given kya hai, that is weight of solute, that is sodium hydroxide. This is the solute because I already told you that is NaOH mixed with water to make a solution. Okay, this is an aqueous solution. So the mass of sodium hydroxide is given to you 50 gram. The mass of solution is given to you 250 gram. Isn't it? Yes, right. So given W of NaOH has given to you 50 gram. Okay. So now the mass of solution is given to you. If I put the law of conservation of mass over here, right? So the mass of sodium hydroxide plus the mass of water must be equals to the mass of the solution, right? So here I can write that is mass of solute plus mass of solvent must be equals to what? Mass of solution as per what? Law of conservation of mass. So here the mass of solutions is given to you. The mass of solution is given to you as 250 gram. So if I want to calculate the mass of solvent, so the mass of solvent means water is a solvent. So here the weight of water will coming out to be 250 minus 50. It's coming out to be 200 gram. Isn't it? Yes. So now the question asks that the mass percentage of water I need to calculate. So here look into the formula what I have given you, that is percentage of solvent equals to what was the formula, weight of solvent by weight of solution into 100. So let's do it. So what is the weight of solvent I got from here? Is it 200 gram? So if I want to calculate the percentage of water, so it will be 200. What was the total mass of the solution? This is already given to you. It is 250 into 100. So here it is coming out to be 200 into 100 by 250, and it is divisible by 5, I guess. This is 40, 50, 2, it's coming out to be 80%. Okay, so in the total solution, the water composition is 80%. So this is how we can calculate the mass percentage of any solution. Okay, and we already understood what is the meaning, what is the actual meaning of weight percentage term. That means if weight by weight has given, so we will assume the solution is 100 gram, and we will consider whatever the solute and whatever solvent is given to we will consider the weight out of the 100 gram of the solution. That is called the percentage or weight by weight percentage. Okay, let's look into the mole fraction. Okay, mole fraction. So whenever I'm talking about mole fraction, so this comes under the term of fraction term. It means if I'm talking about mole fraction. Okay, if I'm talking about mole fraction means there is a fraction term. Matlab, it will be in the form of x by y. This is a fraction term, right? So it will be in the form of x by y. So what is called mole fraction? Whenever I'm talking about that, let's suppose there is a mark distributions in a result, right? Let's suppose I scored 60 in physics, I scored 65 in chemistry, I scored 70 marks in maths. All right, so what will be the total marks? So if I'm talking about total marks, so it will be 5, 6, 6, 12 and 7, so it will be 19. Total mark is 195. Okay, so the total mark of the 3 subject will be 195. Okay, if I'll ask that what is the fraction of the mark you have achieved or you have scored in the chemistry out of the total mark, so what you will do? You will do what? That is the fraction of chemistry, fraction of marks of chemistry, mark of chemistry will be like, you have scored how much mark in chemistry? 60, 65. So here you will 65 out of the what? Total mark. Like this is your fraction, and if you multiply with it with 100, then you will get the that what percentage you have gained in the chemistry, specifically in chemistry. So what I'm trying to tell is that whenever you are multiplying the 100 in the fractional term, you will get the percentage term, right? So here it has asked the mole fraction. Matlab, if I'll multiply the 100 in the mole fraction, I will get the mole percentage, right? So returning into the fraction term, that is out of the total mark, what is the exact mark you have obtained in the specifically chemistry. So if I will relate these things to this, so what I can conclude that mole fraction has given to you, right? So mole fraction, and we are calculating the concentration term for what? Solutions. So if I'm talking about solution, so there will be two part of solution, right? One is your solute part, another part is your what? Solvent part. So if I'm talking about likewise the previous example, let's suppose this is physics and this is chemistry, right? So you have this is the mark of physics, this is the mark of chemistry. Okay, so if I want to calculate the fraction of physics mark out of the total mark, what I was doing that is fraction of chemistry marks equals to what I was doing, that is the mark obtained in chemistry, by the total mark, I was doing this, right? So if I want to relate to the mole term, what I will do, if I want to calculate the mole fraction, okay, if I want to calculate the mole fraction of solute or solvent, let's suppose I'm taking solute. Let's take this as A, this is B. Okay, so if I want to relate the mole fraction term to this fraction of chemistry mark obtained, what I will do? That is the number of moles of solute present in the total number of moles of the solution. I can select this, right? So if I'm talking about the solute, so let's suppose the number of moles of solute is A. Let's suppose the number of moles of solute in the solution is Na, and the number of moles of solvent in the solution is Nb. So if I want to calculate the fraction of the solute, what I can do? That is the number of moles of solute, that is how many number of moles of solute A has present out of the total number of moles of the solution. So I can write it like Na by it will be Na plus Nb. isn't it? Okay. Similarly, if I want to calculate the mole fraction of solvent, okay, if I want to calculate the mole fraction of solvent, what I can do? I can do that is then how many number of moles of solvent has present in the total out of the total moles of the solution. So I can do like this, that is number of moles of solvent, that is number of moles of B by the total number of moles, that is Na plus Nb. Okay, so I can do like this, that's the mole fraction of solvent, and this is the formula to find the mole fraction of solid. Okay, note it down. We will do a questions on it. Okay, if anybody wants to take the screenshot, then you can take the snapshot, then we will move to the another. Okay, let's do a problem on it, how to find the mole fraction of solid and mole fraction of solvent. Let's take an example. Let's suppose there is a question is given to you like 60 gram of urea mixed with uh oh sorry mixed with 18 gram of water to give a solution, okay, and the question is asked, calculate the mole fraction of urea as well as the mole fraction of water. Okay, so what the question is given, that is when you are mixing 60 gram of urea, what is the formula of urea? You might have known, NH2CO NH2, right? So this is the formula of urea. So 60 gram of urea has mixed with 18 gram of water to give a solution. Like 60 gram of urea in a container, and I put 18 gram of water in that, and I mixed this to solid and solvent to form a solution. Okay, then calculate the mole fraction of urea. Okay, so I have to calculate the mole fraction of urea as well as the mole fraction of water. Okay, so from these questions I got to know that is urea will be the solute, water will be, let's suppose, the solvent. Okay, it must be a concentrated solution, of course. So what is the weight of urea given to you? It's 60 gram, isn't it? Okay, so what is the weight of water has given to you? It's 18 gram, right? Okay, so in order to find the mole fraction, if I put the formula in the mole fraction formula, so first I need to calculate the number of moles of urea and the number of moles of water. So if I'm supposed to calculate the number of moles of urea, what I can do, what is the formula with me to find the number of moles if the weight is given? I have already told you, that is if the weight of any substance is given to you, how to find the number of moles? I can calculate the number of moles by putting the formula, that is given mass by molar mass. Okay, so here if I want to calculate the number of moles of urea, I have to put the formula, that is weight of urea that is given to you by the molar mass of urea, Okay, what is the weight of urea given to you? It's 60 gram, right? Urea ka molar mass, what will be the molar mass of urea? So here NH2CO NH2. Okay, so here 2 moles of nitrogen is given, so 2 into 14 plus. There are 4 moles of hydrogens are there, so it will be 4 into 1 plus 1 mole of carbon is given, so 1 into 12 plus 1 mole of oxygen is given, so 1 into 16. Okay, so if I want to like sum up this all values, what I'm going to get, 14 into 2, it's 28 plus 4 plus 12 plus 16, so it is going to be 60 gram per mole. Matlab 1 mole of urea is weight to be 60 gram. Okay, so the molar mass is coming out to be again 60 gram. So here the number of moles I'm getting is number of moles for urea is 1. Okay, if I'm talking about number of moles of water, okay, number of moles of water, because I found the number of moles of solute. Now I have to find the number of moles of water, that means the number of moles of solvent will be again given mass of water by molar mass of water, by molar mass of water, by molar mass of water. So the given mass of water is given to you 18 gram. All right. And what is the molar mass of water? Molar mass of water is again 18 gram because 16 plus 2 water, right? So here it is also coming out to be 1 mole. Okay. So now I am having the number of moles of urea as well as I am having the number of moles of water. So if I want to calculate the mole fraction of for urea, so what I can do? The mole fraction of urea will be, so usually the mole fraction is represented by a sign that is chi. Okay, this is chi. Okay, so here chi of A. So I'm representing the urea as A. Okay, and I'm representing the solvent that is water as B. So what I can do here, the chi A will be equals to number of moles of A by the total number of moles, that is the total number of moles of the solution, because mole conservation law will be applicable here. So here the number of moles of A plus number of moles of B, it means the number of moles of solute. If the number of moles of solute will be added to the number of moles of solvent, I'll be getting the total number of moles of the solution, isn't it? So here the number of moles of A I found 1 plus the number of moles of solvent I found 1. So the total number of moles of the solutions will be 2. So here I can write that is the number of moles of A is given to you 1 by the total number of moles of the solutions will be 2. So it is coming out to be 0.5. Again, if I'm talking about the mole fraction of B, that means if I want to calculate the mole fraction of the water, so here also it will be number of moles of B by the total number of moles, that is Na plus Nb. So here I'm going to having 1 by 2 equals to again 0.5. So if I want to calculate the mole percentage, if the question is asked what is the mole percentage comprising of urea, comprised by the urea, and what is the mole percentage comprised by the water. So here if I have already told you, in order to find the mole percentage, what you can do? You can simply multiply 100 with the mole fraction, Okay. So if you want to calculate the mole percentage of, A, it means urea. So what I can do? I can simply multiply 100 into 0.5. So it is coming out to be 50%. Here again, if I want to calculate the mole percentage of B, so I can calculate 100 into the mole fraction of B, that is 0.5 again, so 50%. So I can write out of the solution, or in the whatever solution has met, like by mixing up the urea and the water, so the urea has comprised 50% and the water has comprised 50%. Okay, so if anybody want to take a snapshot, then take a snapshot, then we will move forward. All right. Okay, so the next concentration term is coming to the picture is molarity. So let's discuss about molarity. What is molarity tells about? Now molarity is a concentration term, and I would like to tell you that there are some concentration term. Some of the concentration term depends on the temperature, like if you increase or decrease the temperature, if you change the temperature, then the concentration will also change. Similarly, there are some concentration terms where independent of temperature. That means there will be no effect on the concentration if we change the temperature. Like if we increase the temperature or decrease the temperature, there will be no effect on concentration, or there will be no change in the concentration. So there are several terms which are actually dependent on temperature. Like if we increase or decrease the temperature, the concentration term will also vary. So I want to tell you here itself, that is, yeah, if I'm talking about the percentage term, that means weight by weight percentage, right? So weight by weight percentage will be in temperature independent, term, because as we know that temperature has no effect on our mass, right? Let's suppose if I'm taking an example, like let's suppose we're taking the example of ourselves. Let's suppose if my weight is 65 kg. So if the summer season, in the summer season, I'm not going to lose my weight, or I'm not going to like gain some weight. In the winter season as well, like I'm not going to lose any weight, or gain any weight. So if there will be a temperature difference, like let's suppose this is a summer season, right? So if I'll be in the outside, so my weight will be 65 kg. And if I'll get into an AC room or a chilled room, like where the temperature has maintained to 16 degrees centigrade, so I'm not going to lose any weight or gain any weight, right? So here, similarly, the mass of solid and mass of solvent is never going to change with the temperature. So I can say that is, yeah, this is a temperature independent term. So now, if I'm talking about the mole fraction term as well, okay, mole fraction term as well. So mole fractions will also be in temperature independent term. Here also the mole fraction is not going to change with the temperature, like despite of increasing temperature or decreasing temperature, the value of mole fraction is going to be remain fixed. It will not be changed with the temperature. So here I can say that is this is an temperature independent term. Here also this is a temperature independent term. Okay, let's talk about the molarity. So I want to give you a trick that in any concentration term, if the volume thing is coming to the picture, okay, let's suppose if I'm talking about the molarity, if I'm talking about the molality, so if I'm talking about the formality as well, so here the volume term is coming to the picture. So as we know, that is volume and temperature. Okay, so these are like, if you change temperature, so the volume will also change, right? If we'll like let's suppose I'm increasing the temperature, okay, अगर मैं temperature increase करता हूँ, so volume of the solution is going to be changed, right? So here if the volume term, here I want to give an example, that is, let's suppose volume, right? If we change the volume, okay, change in volume, change of volume takes place with change in temperature, with change in temperature. So I can say that is the concentration term, the concentration term which depends on volume are temperature dependent, are temperature dependent, are temperature dependent, I can easily say, isn't it? So if I'm talking about molarity, so yes, this is temperature dependent. This is temperature dependent because the volume term is coming to the picture. If I'm talking about the normality, yes, this is also temperature dependent. Here the molality, there will be no, like this is temperature independent, like whether you will increase the temperature or decrease the temperature, the molality value is not going to change. So here this is temperature independent. This is temperature independent. This is temperature independent. If I'm talking about the formality as well, so as yes, the formality is like what the solution's volume has involved with this like concentration term. So here also this is a temperature dependent term. Again, this is temperature dependent. This is temperature dependent. All right. Okay. Now we are going to, okay. Okay. Now we will also discuss that how the if I'll increase the temperature, then how the volume is going to be changed. Okay. So here I'm talking about the molarity. So what is molarity tells about? That is, this is molarity can be expressed. Molarity can be defined as molarity can be defined as molarity can be defined as the number of moles of solute, the number of moles of solute present present per per 1 liter volume of solution, volume of solution. Okay, it means molarity can be defined as that's how many moles of solute has present in 1 liter volume of solution. If I take the volume of solution as 1 liter, so 1 liter solutions contain how many number of moles of solute that can be represented, or this is defined as the molarity. So I can easily, so here I can also write that is it is represented as, it is represented by, it is represented by capital M. So whenever we are like representing the molarity, we will represent it by a symbol that is capital M. So I can write the formula. Okay, I can represent the formula as molarity equals to number of moles of solute, number of moles of solute by volume of solution, by volume of solution in liter, in liter. So it's inevitable that you need to keep the volume of solution always in liter. If in the question sometimes in the questions it will be given with ml, so we need to convert to liter. First we need to convert the volume of solution into liter, then we will calculate the molarity, and in the numerator we will keep the solute, or we will take the number of moles of solute. Okay, let's do our questions. So and already I told you that this is a temperature dependent term. Okay, so this is a temperature dependent term. This is a temperature dependent term. Okay, let's talk about the molarity, or let's understand the molarity with the questions. For example, if I'm taking a question that is 50 gram of calcium carbonate mixed with enough amount of water, enough amount of water to make a solution, to make a solution of 250 ml volume. Then calculate the molarity, calculate the molarity of the solution, Okay, so what is the question has told? That is, you are mixing 50 gram of calcium carbonate with enough amount of water. I'm taking a container and I'm putting 50 gram of calcium carbonate in that, and I'm putting water and I'm stirring simultaneously, and I have to maintain the volume of the container till 250 ml. Okay, are you getting my question? What I'm telling? Let's suppose this is a container. Okay, so here let's suppose the mark has given this is 100 ml, 150, 200, 250 ml. Okay, so in the laboratory you will be having measuring, like whatever will be there, the measuring flask and all, so you can keep the volume till 250 ml. So what I'm doing, so here I am putting the calcium carbonate of weight 50 gram. Okay, 50 gram, and I'm pouring water on it, and I'm maintaining the volume till 250 ml, Okay, now the question asks, what is the molarity of this solution, right? Okay, so from the given data, I'm pretty much sure that I can find, that is, what are the given data, that is solute. What is the solute? The solute is calcium carbonate. Okay, so what is the weight of solute is given to you? So weight of CO3, CaCO3 is 50 gram. Okay, what is the solvent? This is water, and the volume of solution is given. The volume of solution is given to you is 250 ml. Okay, and the question is asked about the molarity. What will be the molarity of the solution? Okay, so let's calculate the molarity. So if we put the molarity formula over here, so molarity equals to, I know, that is the number of moles of solute, by volume of solution in liter, isn't it? Okay, so in order to find the molarity, what are the things I need? That is the number of moles of solute. So first I need to find the number of moles of CaCO3, isn't it? And for the denominator, I have to find the volume of solution in liter. All right. So if I'm talking about the number of moles of CaCO3, what is the formula I'm present with? It will be given mass by molar mass, right? So what is the mass given to you? It's 50 gram by, what is the molar mass? Calcium is 40, carbon is 12, and oxygen is 16. So 16 into 3, it should be 48. So 48 plus 12, 60 plus 40, 100, right? So it is 100 gram. So here it will be 1 by 2, that means 0.5 more. Okay, so I found the number of moles of calcium carbonate is 0.5 more. Okay, so now the thing is that I have to find the volume of solution in liter, right? So the volume of solution is given to us 250 ml, right? As we know that 1 liter is 1000 ml, right? So if I want to find the volume of solution in liter, so I can write that is 250 by 1000 liter, isn't it? So let's put the value in the formula. So I'm going to have 0.5 over here in the numerator as the number of moles is given to you. By the volume of solution in liter, it's coming out to be 250 by 1000. Okay, let us solve it. So 0.5 into 1000 by 250. Okay, so we can write 5, right? 5 into 100 by 250. Okay, so here I can cancel this 50, so 2, so it is 2 molar, or I can easily write it like or 2 moles per liter, moles per. Okay, so I can easily find the molarity of the solution as 2 molar or 2 moles per liter. Okay, so this is how we can easily calculate the molarity of a given solution. Okay, so if I want to take a snapshot, then take the snapshot, then we will move. Okay, let's look into another questions. Like most of the time, like you are given with the density or the mass percentage. Okay, so several kind of questions can be made like using the concept of molarity. So let's look into another question. Let's suppose I'm taking a question that is, let's suppose 4 gram of 4 gram of sodium hydroxide mixed with mixed with enough amount of water, enough amount of water to make a solution, to make a solution of 500 gram, having having density 2 gram per ml. Okay, and the question is asked, find the molarity, find the molarity of the solution, of the solution. Okay, let's solve this question. Okay, now look into the questions. What is given to you? It has asked that it is asked to calculate the molarity. So what is given to you? You are given with 4 gram of sodium hydroxide. That means you are given with the mass of solid, of course, and that will mixed with enough amount of water to make a solution of 500 grams. So here the mass of solution is given along with the data of density. Okay, so by doing something or by solving this density and mass, because we have to solve with the relations of density with the volume, isn't it? So we have to find the volume of the solution, then we need to calculate the molarity of the solution. So here, in order to find the solution, let's write what is given to you. So the mass of sodium hydroxide is given to you as 4 gram, right? And the mass of solution, the mass of solutions has given to you 500 gram, and along with that the density of the solutions has given to you, it is 2 gram per ml, and we know that is the density of the solution is given as mass by volume, isn't it? So if the density of solutions is given, so I will take the mass of solution in the numerator, the mass of solution in numerator, by the volume of solution in denominator. So the volume of solution in denominator, in denominator. Okay, now let's solve it. So the density has given to you 2 gram per ml, 2 gram per ml equals to the mass of solution has already given in the question, that is 500 gram, by volume of solution I need to find, or by solving this I can find the volume of solution. Okay, let's solve it. So if I want to volume of solution in ml, because of course if I divide it the density like with the mass, then I am going to, if I'll solve this question, so the volume I'll obtain in the ml, milliliter. So here it is going out to be 500 gram by 2 gram per ml. So here it is coming out to be 250. Here gram will be cancelled out with gram, and here this ml will be here. So this is 250 ml. So I obtained the volume of the solution is 250 ml. Okay, it's 250 ml. Okay, so in order to find the molarity, I'm having with the volume, right, in ml. So I need to convert it into liter. And another factor what I need, or what is the prerequisite for to find the molarity, I have to find the moles of the solute. So in order to find the moles of solutes, the mass is given to you. So the mass is given to you. So in order to find the number of moles of sodium hydroxide, what I can do, that is a weight of NOS or weight of sodium hydroxide by molar mass of sodium hydroxide. I know this formula. So by using this formula, I can easily find out the number of moles of the sodium hydroxide. So what I can do? So NaOH, right? What is the molar mass? Sodium is 23, oxygen is 16 plus 1. Okay, so it will be approximately equals to 0, 40, isn't it? So 40 gram per mole, 40 gram per mole. So in order to find the number of moles, so the number of moles of sodium hydroxide will be, what is the weight given to you in the question? It's 4 gram. Okay, so let's put it. So 4 by 40. Here 4 by 40 equals to 1 by 10 equals to 0.1 mole. Okay, so the number of moles I'm having is 0.1. Now put all this data in the molarity formula. So here the molarity formula is coming out to be M equals to number of moles of sodium hydroxide, number of moles of sodium hydroxide by volume of solution, in liter, isn't it? So here it will be 0.1 mole, because this is the mole of sodium hydroxide, which is a solute, by volume of solution in liters. So here the volume of solutions is given in 250 ml. So I need to convert it into the liter. So here I can put that is 250 ml by, well, divide it with 1000. So this ml term is converted to liter. So here 0.1 into 1000 by 250, right? So if I'll cancel 1000 with 250, I'm going to obtain 4, and here 0.1 into 4, I'm going to 0.4 molar. Okay, or simply I can write 0.4 moles per liter, moles per liter. Okay, so this is the required molarity for the solution. Okay, okay, take a snapshot of this. Okay, let's talk about another type of questions. Okay, let's talk about another type of questions. Suppose you are given with a question that you are given with a solution of certain molarity, and you are diluting the solution with water, and you are just changing the volume, and the question is asked that what will be the new molarity. For example, let's suppose I'm telling you are given with a solution in a container. Okay, here let's suppose here, for example, if I'm telling that you are giving 50 gram of sugar, you are adding 50 gram of sugar with 1 liter of water, and you are preparing a solution. Let's suppose this solution is 1. All right. Yeah. So in this solution, if I'm talking about the concentration term, if I simply understand this, so I can tell that what is the sweetness of this solution. So let's suppose I just take a spoon of the solution and I test it. Then what I did, I added again 1 liter of water into it. Right? I have prepared the solution with 50 gram of sugar and 1 liter of water. Again I added 1 liter of water into it. So, and I diluted it, and the volume has turned to be 2 liter. The volume has turned to be 2 liter. Now tell me one thing, is this 50 gram of sugar also changed? No, right? So the 50 gram of sugar in the solution remains constant. I just change the volume of the solution to 2 liter. Similarly, So if the mass of the solute in the solution 1 has not changed in the solution number 2, so it means the moles of solute also remains constant, isn't it? So by taking this concept into mind, if I say that there is a solution number 1, there is a solution number 1 having M1 molarity and V1 volume. This is solution number 1. Solution number 1. This is having M1 molarity. There is a certain molarity. Let's suppose 0.5 molar, 0.1 molar. Anything is given to you, and you are given with a certain volume. Okay, and you are diluting it with some amount of water, and you are obtaining another solution or the diluted solution. This is the diluted one of volume V2, of volume V2. And let's suppose the question is asked that what will be the new molarity. Okay, so let's suppose this molarity will be M2. This is the new molarity. So if I want to build a relationship between the first solution and the second solution, as I already told you in the previous example, that in the previous example, as the 50 gram of sugar is not going to change by adding few amount of water or as much as amount of water you want to add to the solution number 1, the mass of the sugar is not going to be changed. So here also, whatever number of moles solute was already present in the solution number 1, if you are adding any amount of water to it, so the number of moles of solute in the solution number 1 is not going to change. That will be remain fixed. So if I want to say that I am taking the formula of the molarity into consideration, so I can say that is M1 molarity must have found by the number of moles of solute by volume of solution in D2, right? So here also, if I want to find the M2 by the formula, M2 must be the number of moles of solute which is not changed yet. So here the number of moles of solute will be same as the solution number 1, that will be N1 by the volume has changed, of course, because if you dilute it, like if you add some water, you diluted it, the volume has changed. The volume has changed from V1 to V2. So here I am taking the new volume as V2. Okay. So if I want to say that N1 is equals to M1 V1, here N1 equals to M2 V2, isn't it? So I am representing this entity and this entity for the same number of moles, right? So from the basic maths, I can just equalize these two. So here I can say that is M1 V1 equals to M2 V2. So this is the relationship between the old molarity and the new molarity after the dilution, right? So let's solve a question. If you want to take a snapshot on it, so you can easily take a snapshot. Now, let's talk about a question, okay? If 0.2 molar NaOH aqueous solution is diluted to 5 liter by adding enough amount of water, by adding enough amount of water, then find the new molarity, of the diluted solution, okay? A simple question is given to you, that is, it is asked, that is 0.2 molar of sodium hydroxide aqueous solution. So here you are given with that there is a solution number 1, okay, which is 0.2 molar NaOH aqueous solution. So that means 0.2 mole of sodium hydroxide is present in 1 liter of solution. I can easily write solution number 1 equals to 0.2 mole of sodium hydroxide is present in 1 liter of solution. Okay, so what I am doing, I'm diluting it with water. How much water? That has not mentioned. So it's just saying that is you diluted to 5 liter. Okay, then must be I'm adding 4 liter of water. Right. So the final volume V2 has given to us 5 liter. So the V2 is a solution number 2. The volume has given to us 5 liter. Okay. So from these questions, I can easily see that is the M1 has given to us 0.2 molar. V1 is given to us 1 liter because of course the no volume has mentioned. So I'll consider it as 1 liter because 1 liter volume is containing 0.2 moles of sodium hydroxide. Here the volume of the solution 2 has given to 5 liter. So it has asked what is the new molarity. So I'm putting the formula, that is, see, by diluting it, the 0.2 moles of sodium hydroxide is not going to change. That will be remain same no matter till which volume we are setting it up, right? So here also I am taking the formula M1V1 equals to M2V2. So M1 is given to you as 0.2 molar into the volume is given to you as 1 liter. Here the M2 has asked, so I don't know about the value or I need to calculate it into V2. So V2 has 5 liter. Okay, so the M2 is coming out to be 0.2 by 5, isn't it? So I can calculate as that is 2 by 10 into 5. So this will be 2 by 50 molar. Okay, or you can just easily solve it to a decimal form. So 2 by 50 moles per liter will be the new volume of the diluted solution. So this is how we can also solve the questions of dilution. Okay, now looking into another type of question that like the NEET and JEE, the NTA frequently asked, that is, let's suppose there is two solution. Okay, one is your solution number 1 of some another solute, and there is another amount of solution like solution 2 with some other solute. Let's, for example, I'm taking in the solution number 1 glucose is present, and in the solution number 2 urea is present, and I am uh, picking some volume from the solution number 1 and some volume from solution number 2, and I'm mixing it up, and I'm asking what will be the total volume of the solution. Okay, so we will just solve it in a unitary method first, then I will give a formula upon it. Okay, so let's solve it. First okay, we will understand this question with an example. So let's 60 gram of urea mixed with 2 liter of solution, and in another container 18 gram of glucose mixed with 5 liter of water, 5 liter of water, sorry, mixed with water here, mixed with water to make 2 liter of solution. Here also I'm just taking because 5 liter of mixed with water to prepare 5 liter of solution, 5 liter of solution. And again I'm asking, that is, this is in container number 1 and this is in container number 2. So if 750 ml of solution from container number 1 is mixed with 500 ml of solution of container 2 from container 2 mixed with 500 ml solution from container 2 to another container 3 find the molarity of the new solution in container 3. In container 3. Okay. So what the question is asking about, that is, in a container number 1, you are mixing 60 gram of urea with enough amount of water to prepare a solutions of 2 liter, and there is another container where you are mixing 18 gram of glucose with enough amount of water to form a 5 liter of solution, and you are taking 750 ml of solution from container number 1 and you are taking 500 ml of solution from container 2, and you are mixing those two solutions separately in a container number 3. So now the question has been asking, that is, what is the concentration of container number 3 solution? Okay, let's solve this question. So first of all, I need to find that what is the molarity of the solution number. First, I need to calculate the concentration. So in the container number 1, what is the solute? The solute is urea. So urea has given you to be 60 gram. So number of moles of urea is found out to be 60 by 60 given mass by molar mass, that is coming out to be 1. And the volume has given, the volume of solution has given to you is 2 liter. Okay. So the normality or the molarity, sorry, I mispronounce M1, molarity, or the molarity of the solution in the container number 1 will be number of moles of urea by volume of solution in liters. So 2, this is 1 by 2, so it's coming out to be 0.5 molar. Coming to the container number 2, so what is the solute you are given with? Your glucose. So glucose is the solute, and the mass of glucose has given to you is 18 gram. So what will be the number of moles of glucose? So number of moles of glucose will be 18 by 180. It is coming out to be 1 by 10. This is 0.1 mole. And the volume of solution is given to you as 5 liter. So volume of solution equals to 5 liter. So the M2 will be 0.1 by 5 molar. Okay. Now I'm talking about, that is, in the question it has asked, that is 750 in from the container number 1. I took 750 ml, and in the container number 2 I took 500 ml. So let's solve it in the unitary method first. So if I'm talking about the container number 1, that is 0.5 molar. So can I say, that is, container number 1, from the container number 1, 1000 ml of solution, 1000 ml of solution contain 0.5 mole of solid. So 1 ml of solution must be containing 0.5 by 1000 ml by 1000 moles of solid, isn't it? If 1000 ml containing 0.5 mole, then 1 ml must be containing 0.5 by 1000 mole. So I took how many ml? 750 ml. So 750 ml of solution must be containing 0.5 into 750 by 1000 moles of solid. Right? So this much of solute I have taken from the container number 1. Now I need to find that how many moles of solute I took from the container number 2. So if I'm talking about the container number 2, so in the container number 2, let's solve it. 1 by 10 into 5, 1 by 15, so it will be 0.02, I guess, 0.02. So this will be 0.02 molar, right? Now 0.02 molar. So in the container number 2, that is 1000 ml of solution contain 0.02 mole of, what is the solute? Glucose, I guess. Yes, glucose. Here it is urea. So 0.02 mole of glucose. So 1 ml of solution must be containing 0.02 by 1000 ml, sorry, 1000 mole of glucose, isn't it? Yes. So I took how much volume of solutions from container number 2? I took 500 ml of solution. So here I can say that is 500 ml of solution must be containing 0.02 by 1000 into 500. So it is 2. That means 0.01 mole of glucose. Now tell me one thing. If I'm mixing these two solutions, so the number of moles will also be added because ये दोनों जो भी हो, so whatever is the solute, they are addable, like these two can be addable. So if I'll adding this 2 moles of solution, whatever I obtained from the 750 ml of solution, whatever I obtained from the 500 ml of solutions, so the moles of the solutions can be added to each other, right? So the total number of moles, I can say, that is the total number of moles of solute in container 3 in container 3 equals to, okay, so how many number of moles of solute I have obtained from the container number 1? It will be 0.5. It will be 0.5 into 750 by 1000 plus 0.01. You can even solve it. It will be 5 by 10 into 1000 into 750. So it will be 200, right? So here it will be 0, 0. So 5, 15, it will be 40 plus 0.01. So here it will be 15 by 40 plus 0.01. So if we'll add these things, so you will get the total number of moles of solute in the container number 3. Now what is the volume? So volume in container 3. Volume in container 3. It is coming out to be 750 ml of the volume from container number 1 and 500 ml from the container number 2. So what I can do? If we'll add this, so 0, 5, 12. So 1250 ml. So 1250 ml means it will be 1.25 liter. Okay, so for the container number 3, in order to find the molarity, I got the number of moles. You can even solve it. 15 plus 0.01 into 40 by it will be 40. So this is the total number of moles of solute, and you got the volume of solution. So in order to find the molarity, that is M3, what you can do? You can do 15 plus 0.01 into 40 by 40 by 1.25. You will get the total molarity of the solution number 3. Okay, or this is the entire thing of unitary method. So in the entrance examination, we do not have this much of time to solve it in a brief manner. So there is a formula that is called, I can easily calculate, that is M3 equals to, like the molarity of the container will be M1V1 plus M2V2 by V1 plus V2. I can easily calculate the molarity of the prepared solutions by this formula. If you will add this, you will get the same answer as you must have got from here. Okay, so this is all about your molarity. So in the next session, we will start with the normality and the formality, and we will be proceed with our thing like the Henry's law, and we will proceed on it. Thank you so much for connecting.